In example 2, we need to find the partial fraction decomposition for this wonderful expression right here. So let's see if we can factor the denominator. Well, there's a few different methods you can use. There's the good old guess and check, where you can use like the AC method. No, let's try that. So we want to find two numbers. When we multiply them, we get negative 18. So multiply your A and C. And they got to add to be 7. Oh boy. How about 9 and negative 2? Alright, so what that allows us to do is split up. Boy, let me check this here. Oh, you can't see it. That's good. 3x squared plus 9x minus 2x minus 6. I'm getting kind of in the business here of that thing. And then we're going to factor by grouping here. So we've got 3x times x plus 3. Negative 2 can come out. We've got x plus 3. Boy, that gets awful tight there. And then our factors are going to be 3x minus 2 and then x plus 3 here. So we want to list those at the bottom. 3x minus 2 and x plus 3. And you can verify this by reforming it out. So negative 2 times 3 is that negative 6. We've got negative 2x plus 9x, which is 7x. And 3x times x is 3x squared. We need to somehow get a value of a over the first factor plus some value of b over the second factor. To figure this out, we're going to need to multiply by 3x minus 2 times x plus 3, and we'll multiply everything by that. Remember, if you multiply one side of the fraction or one side of the equation by a value, you need to multiply the other side by the same value. And so these guys will be gone, so we'll be left with negative 22. 3x minus 2 is gone here, so we've got x plus 3. And then on this side, the x plus 3 is gone, so we've got 3x minus 2. Now let's solve for a. So we'll do that over here. So that was just factoring the bottom. Solve for a. Alright, we want to pick a good value for x that makes this factor 0. So to do that, you can just set 3x minus 2 equal to 0 if you want, if you're having trouble figuring out what that is. And so we can see here that x should be 2/3. So we're going to let x equal 2/3 for this one. We've got negative 22 is equal to a, and then in parentheses we're going to have 2/3 plus 3. And that's going to be plus b times 3 times 2/3 minus 2. Negative 22 will be a, and then if we add these together, if I get a common denominator, I'm going to make that 3 9 over 3. So that should be 11/3, I think. And then this whole mess is going to work out to be just 0. 3 times 2/3 is 2, and 2 minus 2 is 0, so that whole term is gone. That was our goal in picking 2/3. We'll now multiply by the reciprocal here. So we can cancel 11 and negative 22, and that becomes 2 over 1, or at least cross cancel, I should say. And 3 times negative 2 is negative 6. So negative 6 will be a. So in our final solution, we want to write negative 6 over 3x minus 2 equals, oops, excuse me, wow, I shouldn't have written that. That should have been a plus sign. Alright, and we're going to have some other value here over x plus 3, and that's going to be b. So let's work on solving for b here. We want to find a good value. We're going to go back to this guy. We want to find a good value so that we can get rid of this term with a, and that's a negative 3. So we're going to let x equal negative 3 here. We've got negative 22 is equal to a times negative 3 plus 3. And we've got plus b, and then in parentheses we've got 3 times negative 3 minus 2. Alright, well that term with a is gone now. 0 times a is 0. We've got b, and then negative 9 minus 2 is negative 11. So we'll divide by negative 11, and b will be 2. So we should have a 2 in our answer. So we have successfully rewritten this fraction as the sum of two fractions, or you can say that we've decomposed this fraction into two partial fractions here.